Hi, I'm Keith from Sunsync. This is our office in Hong Kong, our showroom, and we use this as a sort of an R&D teaching platform. So I'd like to present to you our inverter. Now most people don't know what an inverter is. Well, an inverter is a device that converts DC into AC. So typically on a solar inverter for a traditional system, the inverter connects to the solar panels and it connects to the main. So let me show you. So my drawings are terrible, so please excuse my drawing. So this is a solar panel. This is the symbol for solar panel. So you have a solar array which is on your roof, and then you have traditionally an inverter. INV. The panels connect to the inverter, and this then connects to the AC. Now, what happens is when the sun is shining, and then the power will flow into here and it will flow into here, and the AC will flow into your house, or if you have a surplus you might export it. It's called export, or some people call it feed-in tariff, and that's it. It's a very simple system. The problem is two problems. One is nowadays in the UK and all the places you don't get any money for your export, so you're feeding in, or you might get very small amount. And if you're out all day, and so let me explain a little bit further. So this is how the system works. But if you're actually in the house or you're out, so let's look during the daytime. So normal daytime. So we work on a 24 hour. So we talk from 12 o'clock midnight till 12 o'clock midnight. So your power usage. So this line here, I'll try to make it a bit clearer. I'll draw it in red. So this is your power usage. So your power usage might come here, and then say about 7 AM, it will go up a bit, and it will come back down again, and it will do that. And then maybe about 8 PM, or whenever you come home, your power usage will go up, and it will come down like that. So that's a very typical power usage. Now, let us look at the production from the solar, if it's a normal system. So a normal system will be flat there. It will ramp up here maybe, and it will ramp back down again here, and then that's it. Okay, so this is the problem, is because a lot of the time here you've got this area here, and I'll mark it in blues and different colors. Here, this part is wasted. It could be the feed-in tariff if you get it, but it's very little. But here is where you need the power. During the evening, here is where you need the power, and here you need the power. So what's the choice? Well, the obvious thing is battery. So a normal solar system, okay, can't use a battery. A grid-tied system, so most of the systems you see installed in the UK can't fit a battery. What's the difference between our system? So we start off with our solar panels here. And you don't need solar panels. This is the benefit of our system, but I'll use it with solar panels. So we use some solar panels here, and the solar panels connect together, and they connect into the inverter, INV, and the inverter connects to the this is the grid. We'll call it the grid, and this is the house. Right, all looks very familiar. It looks exactly the same as the other system. Two differences. Here we also have a battery. Now, for what it's worth, these are batteries. You see here, these are lithium batteries, and this is sort of a very typical battery, how it would be mounted in the house. So this is a battery. So we have two parts. We have the inverter and we have the battery. Inverter and battery. You may have multiple batteries. You may have multiple inverters, depending on how big your property is. Small property, you may just have one on one. Larger properties, you may have much more. So what happens is the sun shines, as it will do, and the power goes through the inverter and it comes here. Now, at this point on a normal inverter, it will go back into the grid if you're not using it, or the house. But we add something else to the inverter. We add this device. This is called a CT coil. We add this device. And this device is fitted here. And this is a blocker. I'll draw a no-go sign. And this blocks the power. It controls the power. So I can wire that into the inverter here, and this controls it. So if I want to export, if I've got an export tariff, which most people haven't, I can export. This is like a gateway. But the benefit of it is my power will go in one direction. So if I use more power in my house, it goes that way from the grid. If I got too much, if I need too much, but during the daytime, the power can charge through the inverter. It can use that way, but it can also go that way into the battery. The beauty of it is if I'm looking over my period, so as my solar production, and I use different colors as well. So my solar production will do this, come down, is my solar production. And my use production, as I mentioned before, may be over a couple of patterns. So my use production may be this, and this. So what I do then is during the night time or during the hours when there's no sunshine, or if I'm using off-peak electricity, I'll explain that, the power comes from the battery, and the battery starts coming here into the inverter and back out to the grid. So I've got power. We call it maybe midnight sun. The sun is shining all the time. And this is the benefit of the system. It gives you power whether you've got sunshine or no sunshine. Let me explain something else, a completely different scenario. So we're looking at a different scenario. I'm really not very good at the whiteboard, but I'm going to show you a different scenario. So this is, forget solar panel. We haven't got any solar panel. We have our grid, G-R-I-D, okay? We've got a grid, that's our meter. And on the meter, nowadays, we have what they call economy 7, or variable tariffs, off-peak tariff. So basically, the grid connects here, and it will connect to my consumer unit, my electric, and it goes to the house here. In fact, there is no connection here, it's just there. So it goes to my house, and then it feeds all the lights and everything, but lights, and then maybe your cooking or whatever. Okay, it's your house, it's your distribution. And so here is my, I call it my watt meter, my meter, a watt hour. So it's actually a watt hour, I've just got watt meter. And it powers here, and it powers here into the house. Normal, that's everybody do that. But what sometimes you do is you get variable price electricity. So maybe from say 12 a.m. until say 6 a.m. you might get your electricity say at 0.2 pence. So it's 2p, so £0, so it's 2p. Make it a little bit easier. I use 2 pence. So 2p per kilowatt hour. Now this varies. Some providers may charge you 6 pence, 7p, some p, depending on the deal you get. And then from 6 a.m. until say 12, next one, my price goes to 20p. Well, I want to use 2p electricity because I save myself a lot of money. So how can we do it? So we store it like the old storage radiators used to have. So they store the heat at night time, and during the daytime they give it out. So you use what they call off-peak electricity, economy 7. So we store the electricity. So what we simply do is we use a timer. So the inverter is here, and then within the inverter it has a timer. So the inverter connects to the electricity, and the inverter, INV, which is this device, and the inverter connects to a battery, BATT. So it charges the battery. The inverter charges the battery during the evening, and the battery will charge. This is an inverter, this is a battery. This will charge this during the evening. So during the evening, this will charge this. So daytime comes, what does it do? The inverter connects into here, and it powers here. Now, the thing is, most people say, well, hold on a second. It's going to go onto this is the overhead, the power's coming in. They say, well, hold on a second, but this is going to allow the meter to go backwards. It doesn't. We fit in here, we fit in our CT, we call our CT coil, which is, and my drawings are not particularly brilliant, but we fit this coil, and this stops the power flowing back into the meter. So the power from the inverter only goes into the house only. And it's that simple. And I can maybe draw it a little bit clearer. And maybe my drawing is not so clear. I'll show you a slightly different way, maybe make it a bit more understandable. So how a house wiring is. So we've got, they call it a watt hour meter. So you've got a watt hour meter, and here is is the grid. the national grid. Okay, so it comes into your house, and then from there you've got a fuse board with lots of this is an old symbol for fuses. Okay, and you've got all the fuses going to all your lighting or whatever. Okay, and then simple as we connect to one of the fuses, the inverter. So here is the inverter, here, INV, and it simply connects. We put a protection device, what they call an RCD, residual current device, and it connects to here, to the consumer box. This is your consumer box, this is your fuse box in your house. We take on one of the fuses, maybe a 30 amp or a 45 amp depending, and we would also add some sort of an isolator here. So we put an isolator protection device, and that's it. So it wires in, so the inverter connects via an isolator, an RCD, to one of your fuse boards. Simple as. We then have the battery or battery bank, and the battery connects into the inverter. So pretty much here, you see here the batteries, and the wires go into the inverter here. So that is the configuration. Inverter, battery, I might as well mark it battery, B-A-T, and they quite look pretty, you know, they look nice. You know, they're not sort of a whole car battery. You know, this is really nice. These are top class cells, really, really nice cells. These things will last many years. So the battery connects to the inverter, RCD, and it goes to a fuse board. That's the wiring, it's simple as. So what happens is we add the magic, we add this thing here, and this is what we call our CT coil, and this is here, CT coil. And this is the magic, and the magic goes back into this, and then by using this device here, we control the power, and they call it the export. So it can't export power back onto the grid if we don't want to. If we don't have an export tariff, we don't want to, because if we've got no solar panels, what we do is during the daytime or during the evening, we send the power into that battery. Okay, and then it doesn't. The rest of the house just operates as normal. All the lights and everything, no rewiring, nothing needed, nothing special. So your house operates exactly as normal. All we do is plug this into one of the ways on the consumer units. It's that simple. And then during the evening, it charges the battery, and at night time, or when we're using the power, maybe even in the early mornings or whatever, when it's not charging, the battery reverses its power and the battery starts flowing back, and the power will actually flow back here, and it flows here, it flows through the consumer unit onto the buzz bar, and it will flow back out into all your things. And the CT coil here, this is the magic, will stop any flow coming here. It will stop it, and it will also stop, if it tries to flow, it will also stop anything. So this block, so this cable, the cable's physically connected, but by controlling the power and creating this magic by actually controlling the energy. Now, how that does it is done by causing a potential difference, because when you have a potential difference on a supply, so if your supply line here is at say 240 volts and your supply here is at 239, then we won't get any flow back. And you balance this, you balance it very carefully. It's a very careful balance, and this is how smart our inverter is. Now, some cheaper systems don't do this. They're what they call a UPS system. It's a completely different thing. But this system is special. And by using this CT coil and by using this magic, then we can charge the batteries, we can use cheap electricity during the day. And you may save a fortune in your electricity bill, absolute fortune. And this is what they call AC coupled. There is another benefit. There's one other thing. One of the things about the system is, because it's all connected to the AC, if we get a power cut and there's a power failure, then the system will shut down. It has to shut down for safety. It can't. But we have another connection here. We have one more connection here, and we will call it UPS. And this connection here, even if we have a power failure, the UPS will still operate. So if we have a power failure, the UPS, we call it a load or whatever. So what we could do is we may choose, okay, we take out our lights here, we'll call it lights or essential load. If you're in a risky area, you might call it essential load. And we remove it from here and we connect it into here. And that means, and we don't need this wire here, and that means even in power outage, our lights will operate. So our lights will always operate 24/7. So if there's a power failure, the lights will carry on, and maybe our alarm system or whatever. So this is by using this additional feature. It's built in, there's no extra. So this is a basic use of our system. It's beautiful, it's beautiful. You look, we have a most amazing software. Our software, by touching, we actually create a screen, and the screen actually shows the flow. And you see here, which is the flow, and we actually even draw a little picture. You can see here the flow coming through here, and then it flows into the inverter. You see the current. So this is from the grid, and this is the power going out into the UPS. And in fact, if I go on to one of the other things, you'll see here, I have the CT coil. So I actually mark, now this is not connected to a load, but I can see what the CT coil is. I can see the voltage. And if I choose to put solar panels in, because this thing can be retrospective. If you've got solar panels, great, it's extra power. If you've got solar, but you don't need to fit solar panels. And also it's quite an expense, it's scaffolding and everything else. So if you haven't got them, great. If you've got them, great. It's good, whatever you choose your budget. So this is special, and this is quite a special. So this is what I'm trying to explain, why you need to use batteries for a house. And coming to the future, I'm sure in the UK, every household will have a battery. The government's got to encourage more and more people, because this will save a fortune. It's going to reduce the load on the network, because a generator runs 24/7. You can't stop it. They reduce a little bit, but we're not going to, at night time, we can't switch off a nuclear generator. So, a nuclear power station. So because of that, the thing is running all of the time. And basically, we take advantage of it, and the power companies will want you to, because if every house in the UK does this, it will save us the cost of a couple of nuclear power stations. It's absolutely ridiculous. We've got to go that way. So these are the things, the inverters. You can use banks of batteries. These are lithium batteries. You've probably heard lots of topics talk about lithium battery. These are lithium battery. We can use what they call AGM batteries, which is a cheaper solution, but they don't last as long. The thing with the technology, it moves forward. You can, we don't even have to have it in the house. We can use it in here. You see on the cabinet. So this can be, for example, if we're just using it for power storage, we call this power maker, where we have the inverter, and we can put the batteries in a rack. And so the nice thing about this is a fully waterproof cabinet. This is a waterproof cabinet. This can sit out, for example, an interesting usage for this. And I show you another usage. I try to explain a lot of this, and I'm probably boring you all to death. But if you've got, say, for example, on a building site, and I use that because a lot of people, and I know I'm jumping from a domestic, but this is just a sort of general training thing. But if I've got a building site and I've got, say, I'm terrible at drawing, okay? This is my porter cabins, okay? And I've got a couple of these porter cabins on a building site, okay? And I've got a generator. So I've got this generator here, big generator, okay? It's putting out smoke, okay? That's my bit of a generator. And the generator basically is sending the power, the electricity here and here, and it's connecting the electricity. Now, if one of these places has got a peak demand of, say, 8 kilowatt, and this might have an 8 kilowatt peak demand, that means the generator's got to be 16 kilowatt. Now, if I've got my security guy might be there, and this could go on, this could be a big site, this could be lots of usages. So I might have a security man inside the little man, stick man. So I've got the security guy, or I might have people working at night, or I might just have traffic lights on the site, or often just leave the air conditioning running. This generator will be running all of the time. Generators use a lot of fuel. They are so fuel hungry. They are incredibly fuel hungry. So, well, we can use this power inverter. So simply we could connect maybe one here, and we could connect one here, and I'll call this power maker PM. All this is an inverter and a battery storage. So what happens is these are like water tanks. So if you imagine a water tank and the pump, and the water level comes on to full, and when it reaches full, the generator switches off. So this can give our peak demand of 8 kilowatt, 16 kilowatt, 24 kilowatt, whatever you want. This can give it. But the thing is, because you don't need it all of the time, you only need it on demand. You can't be switching off and on a generator, because you turn it off, he's got none. And because the generator, the motor is turning round, you know, a typical generator may be using 100, 200 litres of fuel in a 24 period. By switching the generator off and filling the tanks, the power maker, fill the tanks up, two things. One, we don't need a 16 kilowatt. Maybe we just use a 4 kilowatt generator, much smaller, less fuel. And this will basically fill the tanks up of these are tanks, and these will then power the porta cabins or whatever. They got the peak demand. When they need the 8 kilowatt, they got it. If they run it flat, the inverter will switch on the generator. So this is just showing a typical usage. This can be used in marine, it can be used in lots and lots of things. So my drawings are not necessarily very good, but if I can show you a little bit clearer. So this is what we call power maker, okay? So here is what we call the inverter, INV, okay? And then here is my battery. So I might have a stack of batteries. They look, you know, most people don't familiar with the batteries. These are lithium batteries. This is what they look like. And these things are very heavy. These things are about 50 kilo. So this is a lithium battery. They look pretty much like an old hi-fi unit. There's lots of things going on them. You have a communication port. So here you have a communication because the inverter has to control the charge of the battery. So we have communication. We have the connections, we have power, we have data, we have all sorts of things going on. Don't need to worry about it. This thing does it all. It controls everything. It does it all for you. We have the batteries, have what they call a BMS, a battery management system. The battery management system is controlled by the inverter. So this is our I'll call PM, power maker. This is our power maker unit. Okay, so here we have a battery, a battery, a battery. And we can have lots of power makers. You know, we can maybe have a building site, or for example, if we're in a holiday complex, you know, we could have 100 of these power makers. They could be right around the circuit and all over the place. Okay. The nice thing about it is when you're feeding them off a cable, you get what they call voltage drops, and especially on big sites, you're going to get huge voltage drops. This can handle it. You can control how much you charge the batteries. So this thing, the inverter, charges the batteries. So what you've got is you've got an in and you've got an out. And that's it. In comes off your grid or your network or your generator. Out goes to your building or your crane or your house or whatever. So these are what they look very inconspicuous. And this is what it is. It's simple. It's a simple, ignore my drawings, whatever. And we've got lots of nice glossy data sheets, but trying to explain it to people what it's all about. And this is what I was trying to do today, is just giving an introduction and maybe try to take you through the journey of using the Sunsync product, because Sunsync product can save you a fortune. You know, I've been working on this for many, many years. I've installed personally quite a lot of systems. I know our product. I know how it works. And you know, to coin another, I wouldn't be sitting here giving this video if I wasn't so confident. It is an excellent piece of kit. So thank you for watching this probably short or boring video. I'll upload it and a webcam, and let's look at it. And this is the future. Really is the future. Thank you.